So before we get started, how many of you are actually out there all looking for power? Raise your hand, please. Nobody? And maybe I'd say keep it up if you can get it in the next 6 months. I see one person, 2 people with their hands up. This is great. I want to make sure that I meet you afterwards. We're going to talk about why you don't have to wait and why that's important. And more importantly, why this community building is the most important thing we have going. You heard from Jeremiah earlier. He shared a 20-year perspective. I'm going to give you double that, a 40-year perspective, and the change that we have seen occur and the technologies that we've delivered that you consume daily. And so what we're going to bring is, think back, how many of you were born in 1979? Half of you. What happened then in the power industry that have really changed everything in America forever? It was called 3 Mile Island. I was there. I was in 7th grade. We got evacuated. The next year, my science project was a radiometer where we were harvesting power from the sun so we could power batteries. Fast forward 30, 40 years later, and a company is firing up that defunct power plant because we are so starving for power. I say it has to stop. I say it doesn't need to happen, but you don't have to listen to me because I'm going to welcome up my colleague, Rahul. Come on up here. He's the CEO and co-founder of Hammerhead. And I just don't want you to believe us. I want you to believe the people that invested in where we're going, because we got to do a transaction with our last company to Schneider Electric. And they were the first money in knowing not only is the problem so big and massive, but that it's global. So with that in mind, why are we here and how did we get here? And why don't we take some seats?
Hello, everyone, first and foremost. How are you doing? Good afternoon. Yeah, this is the story of our times, isn't it? I love talking about power. And the reason why we are thinking about power nowadays is it seems that the story has completely flipped. Previously, power was never a first-class citizen. It was never a constraint. You could build wherever. But now, as the intelligence highway gets built, the intelligence railroad gets built, we feel that we are out of power. So is there a solution? Is building more the solution? Let's figure that out. And that's why we're here to talk about it.
Now, when we were preparing, you were telling me about this guy, Sutton, and he talks a little bit about the railroads. Is that what you're seeing transpire here today? And maybe tell the crowd who Richard is and why that's new.
Yeah, so if you haven't heard about Richard Sutton, he's the father of reinforcement learning. And he talks about this concept called the bitter truth, which is brute force building far supersedes any kind of human diligence or human intelligence. What we are seeing right now in terms of AI infrastructure build out is build massive, build with brute force, and therefore we get very quickly to what we call as AGI. Now, is that the only solution? That's what we are here to explore.
Well, if you think about it, if I have to wait for that, and we heard this morning, I got to go apply for a permit, and then I got to pull power, and then I got to get water, and then I got to get land, and then I got to get a box, and then I got to get some racks, and then I got to so this could take 5, 6, 8 years. Do I have to wait that long for power today?
Actually not. If you go down this path, which is exactly what yak shaving looks like, yes, then you do have to wait. Building a brand new power plant takes 8+ years. Getting interconnected to the grid can easily go up to 5+ years. Instead, what we are seeing with AI demand is that moves at the scale of software, timelines of software, whereas infrastructure build out is still very linear, moves at the scale of infrastructure build out. So what do? There is this immense gap where you need to power AI, and then the solution is definitely not wait 5+ years. You can get power now, and that's some of the solutions we are bringing to the market.
Is this theoretical or is this being deployed today?
Interestingly enough, it is getting deployed today. We are working with some of the biggest data center providers that is essentially using our solution to provide power to serve AI loads. We haven't gotten public with all the announcements yet. It's in the works. It's actual proof points that we already have in the bag. It's production deployments, and there's more to come.
Whose GPUs are they running on? Maybe we'll just start unpacking that. Since you can't tell the name of the customer, we can talk about the infrastructure that's running and maybe even the use case.
Yeah, if you throw a stone, it'll land on their rooftop probably. That's whose GPUs we are running there.
Good deal. So now, Is this a global problem, or I was having a conversation, the majority of the build out for data centers is in America. Is this unique to us, or what will they do in Asia?
Look, again, everyone knows AI intelligence is a global, I mean, it's essentially going to be happening globally. The lack of electrons is also universal. And the way we generate and distribute electrons as well as consume electrons is also global. So therefore, the problem is also global. You're going to see the exact same game play out everywhere else. In some cases, market regulations might be different. The way your energy mix works might be different. The utilities might be different, but the story will still be the same.
Right. I saw that where legislation is really making a much bigger impact than we had anticipated just 2 years ago. Are you seeing states say no data centers and putting moratoriums? And what will that do to the AI infrastructure needs? Will it force us to do more with less? Will we be able to harvest today's power?
I think, Bobby, what we're seeing is actually the community lashback to these immense buildouts. And very truly, there is an immense amount of impact, both natural, environmental, as well as community, which is leading to this kind of a lashback. So regulations are there when you have a market failure, and that's why they're coming to the forefront. But what we are seeing is, if you can work with the community and do more with the infrastructure that you already have, you don't have to deal necessarily with regulations, with community lashbacks. You come up with a win-win solution for everyone involved.
Got it. So as we keep going, rather than us just talking, let's see if there's any questions from the crowd before we keep taking you down a little bit of a work stream of the type of workloads and why those workloads are important, and maybe where you see us being in 12 to 24 months. Do we have any questions from the crowd? Yes, sir.
One of the major problems I see is because of the demand between of the power sectors, demand of the data centers. The customer, the consumer, is also paying for the price of the transport of the electrons. Okay, because the grids have to be developed, DC, high voltage, ultra high voltage, that's generally distributed across all the consumers, not just the data. So the pushback is that it actually costs consumers money, and as because all, I would say, all enterprises try to push the cost up as much as they can. So the general population is left holding the bag.
So if I could paraphrase the question, and this is a great question for you given our grid experience. Yes, the energy costs won't go up because it's not like we're going to consume the more energy, but you still need to build out the back-end infrastructure costs, which then goes through a PUC and they get money by actually upping our rates. Is that a summary to it? And that's just really how a utility makes their money. And when you think about it, the unfortunate part is, yeah, you know why? For the last 50 years, we did not invest a thing inside our infrastructure. So it's the most brittle thing that we have here. So I don't know who's going to bear the cost, but I almost say, thank God the AI infrastructure is coming here because we're going to get it hardened. Right? Now, who bears that cost? That's a better question.
Yeah, I think rate increase is definitely something which you are seeing across, and there are multiple ways that people are looking at regulations to curb that. So what we are doing at Hammerhead, though, is something which is completely opposite to like deploying more capital and therefore leading to rate increase. What we are doing is we are going after something that we call stranded power that exists within existing infrastructure. So forget the utility, forget rolling out brand new transmission lines, distribution lines. Can we do more with already existing infrastructure and squeeze the last drops out? That's beneficial because in that case, you don't have to deploy no rate increases. Still, the utilities sell more electrons. They are motivated. You can deploy more capital. You can do more with the infrastructure that you have. And therefore, the number of tokens per dollars per megawatt that you generate in your overall megawatt envelope definitely goes up. So that's what our motivation is, and that's what we're deploying.
What product does that? So it sounds like it's an orchestration layer, which is no different than maybe enterprise data, but with electrons?
Yeah, that's a great question, Bobby. So what we are commercializing is something that we fondly call as Orca, which is our software platform. It stands for Orchestrated RL Control Agents. What that means is it essentially looks inside the fences of a data center, looks at the power available, and then makes decisions across the power infrastructure, which includes cooling, compute, as well as anything and everything that consumes or generates power, and then comes up with algorithms and controls which makes sure you get orchestrated such that you maximize compute while still remaining within that power envelope.
So today, aren't power brokers sort of doing something similar-ish, or is that totally different than what you're offering?
That is very different from what we are offering.
People have brought that up. Like, can I call a power broker for some power?
That's still, I mean, maybe that's a valid solution, but that's not the game that we are in. What we are doing is essentially seeing where there exists power that is underutilized, bringing AI workloads to be able to absorb that underutilized power, and then at the end of the day, generating more tokens with that underutilized power.
Every time I hear that, I just think about getting in an Uber. I got a distressed asset that's sitting on the side of the road that's not doing anything, that through software orchestrates the movement of an electron or a human to a location they couldn't have gotten to an experience they would have never gotten. Is that kind of what it is? So is this Uberization of everything coming to every industry, and is that a good parallel?
I think our Uber is driven by an AI intelligence rather than a driver. So
Right.
That's the only difference, I guess.
What we heard today from Jeremiah, the drivers are all dispatched through AI agents now. So,
There you go.
Yeah. In a way, it's just a way that we're seeing agents orchestrating things being moved, whether you're a human or an electron. So as I unpack that, it feels to me like you should be calling a CFO or a CEO because you're allowing companies to pull revenue forward. Is that a good interpretation?
Yeah, we are definitely looking, we are completely revenue motivated. What that means is right now, AI revenue is power limited. So because we are able to extract more power from the existing infrastructure, everyone benefits. Right from the OEMs, they can deploy more hardware. To people who are selling more electrons, the utilities, they sell more electrons. People who are selling GPUs, again, a stone's throw away, they sell more GPUs. And then eventually, the consumer gets more tokens at a much cheaper price.
Now, as a startup, a lot of the folks in the room are wondering why they should trust Hammerhead, why they should trust you. Have you, when you did this before, something similar, did you get recognized by NIST or by any of the folks for the credible work you did globally on the grid? And should we reflect on that here?
Yeah, but we have seen this story play out before. So I have spent close to about a decade looking at power orchestration for the grid and for the energy markets. We built, again, an ML AI software platform which was able to orchestrate distributed assets and make them resemble exactly like a power plant. So the problem we were solving there was because the grid was also congested, people were building something called peaker plants to meet the peak needs of the grid. Now, these peaker plants would be located exactly where highly vulnerable populations and communities were, and they would burn natural gas and spew all kinds of things into the air. So we were using distributed assets, including thermostats in your home, to replace these power plants. That's exactly what we are seeing play out again, and we are bringing some of those concepts, which, by the way, we eventually sold our company to Schneider Electric. We are bringing those same concepts back, looking at power orchestration within data centers.
Good deal. What happens next after data centers? Because that just happens to be today's insatiable power appetite.
You know, I think if you look at the grid itself, the grid's only utilized about 30% right now.
Wait, what?
Exactly. So that
means... what's the problem with how much power if it's at 30%?
Because everything is peak provisioned. Everything is designed for the worst possible day. It's like, hey, I'm going to have a generator fail. I'm going to have the hottest day. I'm going to have everyone turn on their light switches and electric heaters, water heaters at the same time. And you're going to create this peak. So it's designed for that peak. We see that exact same philosophy play out within the data center as well, where everything is peak provisioned. All CapEx has been deployed to make things very static. And therefore, you're leaving a lot of this power underutilized because you just are still following old school methods of running power. What we are doing instead is making power more dynamic because AI workloads themselves have become a lot more dynamic to be able to absorb these valleys where you don't have absorption of power right now. So therein lies the benefit.
So I'll go back to the question I have. Should just every CFO care about what it is that you do? And it doesn't really matter technically because it's about dollars and cents and power versus compute and what we're doing inside a building?
Yeah, I've never seen a CFO not care about revenue.
I haven't either. Usually the CRO cares more about the revenue and he cares more about the profitability so I can spend the money. But yeah, I hear you there. All right, we're approaching the last 3 or 4 minutes because we got a little bit of a counter late start. So I want to make sure we don't own the agenda and that we take some voices from the crowd. Anyone out there have some questions? This is easy. Either we did a really good job or you don't really need power. You believe everything that we said, which is an amazing thing. So when we think about that, then where do you see Hammerhead in 1 year?
I think we become the central orchestration layer for all AI factories, data centers, and anywhere you have stranded power. We unlock them and bring it in for AI compute. That's our dream. That's our vision. And only the people in this room can make that happen.
Well, what's stopping you?
I guess you have to go through the innovation cycles. We have to still work with people and customers and show that we are actually deploying and creating more value.
It feels to me like we came across a point in time where we have monetizable megawatts. And I think someone, to your question, maybe if these power is sitting there and no one's monetizing and it's a distressed asset, I see the head from Jojo. Does that mean someone else could make power on the power someone already purchased?
100% yes.
So I could like double bubble my money?
100% yes.
What are they doing today with the stranded power? Just letting it sit there on their books?
That's exactly right. Right now, the stranded power is called stranded power because it's sitting on their books, not getting used.
Got it. So in my 40 years, I've seen just about every constraint hit. In the mainframe days, we did it around power actually and what we could put into the envelope of where it went on the raised floor. We then went to client server and we ran out of compute. So we had to move to the cloud, and the cloud we ran out of capabilities and capacity. You had the neoscalers come to a backstop. We saw the same thing with mobility. So I'm not surprised that we're seeing this now with power, but I really want to ask you, does it ever get solved?
I mean, it definitely does. I mean, there
How?
are.
How? Do we like move to the sun?
Or move to Hammerhead.
Yes. All right. We have a question here.
Basically stranded at the negotiated rate with your utility. It's not the power problem, it's the paper problem. Are you solving that?
So it's a paper megawatts problem.
Repeat it for the crowd.
Yeah, so go ahead.
So the question was, today, if I've already paid for the power, I've got a committed price. What's the difference and how can I help you in that situation and scenario?
So they lock you up and say
You got a PPA.
and if you're only taking 2, sure, there's 8 that's stranded.
That's correct.
But you can't unlock that with software. You have to unlock that with the negotiation. And that's human.
I mean, you have hit the nail on the head. You have to do both. And that's exactly what happens. You have to bring all the parties to the table. And by the way, if the utility has given you 10 megawatts and you're only using 2, that extra 8 megawatts of headroom, you're right. There needs to be negotiation as to who's going to use those 8 megawatts. But there also needs to be software capable of monitoring when those 2 megawatts may become 8, may become 6. So it becomes a very, very dynamic as things progress. So forget the utilities in this case. Can you do more with those 8 megawatts is the question. And how do you do that? It becomes a business model innovation question. It becomes a financial engineering question, and it becomes a contractual question along with technology.
And your real question is, I can't sell power because I'm not a utility. And so the real question is there a realm in which we become a utility light that we could resell the power maybe?
If you have over 100 megawatts of power in Santa Clara or California, you are a utility. That's a state law, by the way.
I totally agree. But you're not doing power transactions or energy sales. You have to be careful around that. There are legal regulations around it. So again, like I said, if it was easy, everyone would have done it. But because it's not easy, therefore you need innovation.
This is a great question. Policy, I think, has a big determining factor on how this grows and goes. And it's probably the most underutilized conversation we're having here today, or in general, because if you look at everything that we're seeing, there's very little policy talk. As a matter of fact, I would argue what just happened in Arizona last week, if anyone saw it, where Oracle actually got around the policy by changing the power source to be able to actually comply. And all it really was, I wouldn't say it was a shell game, so to speak, but it was building around the policy versus trying to build what was necessary and needed. And so probably people will go around workarounds. But yes, that's happening. Hence, we started with the state moratorium level. And I'm a big believer that if we engage that, and I've used this with the governor of Oregon last Friday night at dinner, is we don't need to be strip mined by these data centers. We should actually put a data center tax for the state, welcome them in, and then educate all of our people so we don't leave humans behind. These problems are easily solvable. They just have to have to your point, everyone has to sit at the table. Today, what we're solving the problem for is the stranded power in the data center so we don't have to build now. For tomorrow, I think we'll start skating for where does that take place across universities? I'm going to guess across all GSA buildings, across most government facilities. And so that stranded power that we're talking about today is not just going to be that buffer in that data center. It's going to be all over. So we're down to about the last minute. Rather than torch you all, do we have any last questions? If not, my question is, why would you take 5 or 6 years to build it when you don't have to wait? And you can come see us upstairs. We have a handful of folks we'd love to engage and help you. Because if you're short on 100 megawatts, we'd love to chat with you.